Hello, my name is Jaden Finney, and this is Physics Lab 2, titled Charge Tape Revisited. Okay, so the purpose of this experiment is to observe two charged pieces of tape interact with each other using two unique geometries for the system. The first one we had a point charge for Lab 1, and now we have a charge rod. This step comes from Coulomb's law being present in and on everyday objects, including common plastic tape, and that neutral objects can be charged with ease. This includes being rubbed, pulled apart, or by contact. Okay, so in addition to the models used in the previous lab with electric field, electric force being used, as well as the force of gravity, we also have the concept of distributed charges along a rod. The electric field of the whole rod can be expressed by the formula below, and L is the length of the rod, and R is the radius of the rod. Using the force of gravity, we can approximate the charge of the tape. So we have a few more assumptions than we did in the first lab. So we need to treat the tape as a traditional charged rod with length L, L being the length of the tape in this case. Both pieces of charged tape were created with the same method, where it was quickly ripped off a controlled surface. For that, they must have the same charge and will repel each other. As well as three new ones, we must assume only gravity and electric force were acting on the system, charges were equal in magnitude inside the rod, and charges were distributed evenly along the tape. So for the experiment, what we did was we took two identical pieces of charged tape, and tape A was held in the user's hand, while tape B was hanging on two chair backs that I created. As we brought tape A to tape B, at a certain distance, tape B began to repel itself from tape A because we assume that they have positive charges or similar charges because they were made the same way. The tape length was 0.2 meters, mass of tape was 0.0002 kilograms. And we found the separation distance on tape B to be 0.01 meters, around there, and the surface of the tape was 0.0036 square meters. And so after doing some glow scope, this is about what we got for our free body diagram. Obviously, it's much more different than the original, because now we have a line of charges in a rod, and so yellow is the force of gravity, white is electric field, and those green arrows are the electric field along the rod. All right, and this is my glow script code. I just formulated a new formula given the base code. So instead of the point charge, using the formula for a charged rod. And the results what we got was actually very different. We actually got a much larger magnitude of 1.27 times 10 to the negative 7 coulombs, which is about 100 times larger than the calculation from lab 1. So that was really interesting. So what if I had modeled each of the tapes as a single point charge? Basically as lab 1, you'd get the result from the previous lab where we treated the tape as a point charge. And that was actually 5.01 times 10 to the negative 9 coulombs. Not really a difference in code there, just a different formula. So why do these estimates differ? Which value is more likely to be close to the real value? So I'd say these estimates differ because there's two different geometries and two different formulas, honestly. When you take a point charge, everything's just kind of one ball. With the line of charge, it can be evenly distributed across, and because there's a length to it, it can vary. The electric field can vary depending on where you are on the length. And also, it has their own perspectives of sizes of the length and the radius of the rod, or the radius of the point charge. I believe the line charge is actually more likely to be close to the real value, as it accounts for many charges as opposed to one big charge. Plus the tape is shaped kind of like a two-dimensional rod. So in short, we were able to observe the interactions between two pieces of charged tape using two different visualizations, a point charge and a charge rod. Same as the original lab, possible sources of error include contact with hands, humidity in the environment, tape and distance measurements, maybe human error. Taking these into account for a future experiment will result in a more accurate calculation. That is my video, and thank you for watching.